Alrighty, as promised, I'm going to make a video of how to do 13, which will help you do number 14. There's two methods to do it, and the way I'm going to show in this video is how do you do synthetic division involving imaginary numbers. And it's definitely a lot to keep track of, but it's not super impossible, and there's some checks and balances as you go to help you know if you're doing it right or not. So I was given this 0, so keep in mind that means that you know its conjugate is also a 0, which would be 1 plus root 3i. And so I'm going to go ahead and do 1 minus root 3i in the box because it's a 0. I'm going to have my coefficients from here. I don't have any missing powers of x. And so I'm going to just go like that. And actually, knowing where I'm headed, I'm going to spread these little bad boys out a little bit. Okie dokie. So it's the same method as always. It's just a little messier. I drop the 3, and now I still need to multiply. So I'm going to distribute the 3. I'm going to make a little spot over here so to show my work. So I'm going to, someone's knocking on my door trying to give me cash. Okay, so I am going to distribute this, and I'll end up with 3 minus 3 root 3i. So that goes here. And so keep in mind that you can only have the real numbers interact. On the last quiz, one of the popular things to do wrong was positives and negatives. So be careful, pay attention, and remember what you already know. Negative 4 plus 3 is actually a negative 1. And then the minus 3 root 3i doesn't change because there was no I to interact with it before. All right, then I'm going to do the next part, and I'm going to need to multiply those two. So that gets even messier because now I'm going to be looking at foiling. So I need to take 1 minus root 3i, multiply it by negative 1 minus 3 root 3i. So it's not the easiest thing, but you know how to do it. It's foiling. So first is going to be these two, so negative 1. Outside is these two, so minus 3 root 3i. Inside, the negatives cancel, so I get a positive root 3i. And then last, again, the negatives cancel, so I get a positive. I have the 3 from here, but then the 2 root 3's turn into another 3, and then I times I is I squared. So this entire bunch of things turns into 9i squared, which becomes a negative 9 that can now go together with this negative 1. So in the end, putting like terms together, that piece becomes negative 10, because the negative 9 and the negative 1. And then these two in the middle combine to become a minus 2 root 3i. So again, these two real parts go together. 8 minus 10 gives me a negative 2. And then I have my minus 2 root 3i. Now keep in mind, they told you it was a 0. So I expect that in my next round of multiplication, I should get a negative 8. I need a negative 8 in this next spot in order for me to get a 0 at the end. So I'm going to just switch colors so that you can follow the work for each one. And now I'm going to be taking the 1 minus root 3i from out in the box, and I'm going to be multiplying it by what I have down on the bottom, negative 2 minus 2 root 3i. And again, I'm going to be foiling that. So if I do first, and then outside is minus 2 root 3i, the inside, the negatives cancel into a plus 2 root 3i. And then here the negatives cancel, so I'll have a plus. I have my 2. Root 3 times root 3 becomes a regular 3. I times I is I squared. So this ending part becomes 6i squared, or a negative 6, which can interact with that. So negative 6 and a minus 2 is going to become a negative 8, and then these plus and minus 2 root 3i's cancel. So that's good news. because that -8 gives me the 0 that I know I need to get because they told me it was going to be 0. So now kind of the bad news, but kind of the decent news is you have to do it again. Here's why it's not terrible. In this second round, every single time when you have to do another round, it looks like it's going to be awful, but it's actually easier. Because watch what happens. I drop the 3. Now I'm going to multiply the 3 by this, and I'm just going to distribute it without showing that off to the side. 3 times 1 is 3, and then 3 times this second part is going to be a positive 3 root 3i, and notice that cancels. That should happen all the time in the second round when you are multiplying by doing synthetic division by the second imaginary or complex 0. So the only thing left in the second column is a -1 and a positive 3, so I get a 2. And then I'm going to multiply 2 by what's out in front, and distributing 2 to the 1, I get a 2. And then 2 times root 3i gives me this, which is again super awesome because everything here cancels, giving me the 0 I need because I know that that's a 0. And so that is going to get me from my initial x cubed down to an x squared. So at this point, I'm actually at just a linear factor of 3x plus 2. So what does it want me to do? Find all the zeros. Okay, so let's go ahead and do that. My first 0 was given. Don't forget that one. My second 0 was kind of sort of given because I know in my big brain that they come in conjugate pairs. And then my last 0 coming from this is going to be -2/3 because that's what would make 3x plus 2 equal 0. So that is one of your options. That's one of your methods using synthetic division by an imaginary number. You would do the same thing in number 14, so give that a try, and it should play out the same. First time through is messy and gross. Second time through should clear out all of the imaginary numbers. And you always get 2 answers when they give you 1, or I should say 2 zeros. So think about what the conjugate of that will be, and you'll do synthetic division by both of those, and that will land you at something you can solve for the remaining 0. Don't forget, you already know this one, which should tell you this one, and then the last one is the only one you really have to do work to find. Okay, so that is one of your methods. Enjoy. I'm going to call this one the beetle. The other one is the spider, and between the two, I'd probably choose the beetle. Bye.